The overall goal of this procedure is to determine the effects of different directed energy deposition process parameters on the layer thickness and other melt pool characteristics to identify the optimal parameters for fabrication of larger metallic parts.
Directed energy deposition is an additive manufacturing technology for creating metallic parts with medium-large dimensions from metallic powders. Each powder requires process parameters to produce high-density, defect-free parts.
Conventional process parameters optimization often involves waste from over and under deposition caused by assumption for layer height. The main advantage of this technique is that it is time and cost saving.
This optimization method is based on production and characterization of single tracks from metallic powders.
When handling the titanium 6-4 powder, wear a respiratory mask, powder-free disposable nitrile gloves, and protective plastic glasses. To begin characterization of the fresh, irregular titanium 6-4 powder, fix double-sided adhesive carbon tape to an aluminum pin stub for a field emission scanning electron microscope. Apply 3 grams of the titanium 6-4 powder to the sticky carbon tape. Place the pin in the specimen chamber of the FE-SEM and evaluate the morphology of the powder. Then, fill a 30 cubic centimeter pre-weighed container with the titanium 6-4 powder. Weigh the filled container and calculate the apparent density of the powder. Perform chemical analysis of the starting powder using combustion.